Good morning, students. Welcome back to our physics classes. So today we are going to discuss about free body diagrams. Last class we have stopped with finding the forces acting on different bodies when they are placed in some particular situations or particular surroundings. Either they are, sometimes they are placed in the horizontal plane, sometimes they are placed in inclined plane, and in each case what are the forces acting, all these matters we have discussed in the last session. That means last class we have stopped with that. And I told you in the last class, next class we are going to discuss about free body diagram. So free body diagram is used for analyzing a connected system of bodies. A system of connected bodies, in another way. It is a system of connected bodies. Suppose 2 or 3 masses are there or objects are there. They are connected either by direct contact or through with the help of string or ropes, and they are placed in particular situations or particular surfaces. Then what will be the acceleration in each part of the system, or what are the forces acting on each part of the system, and what is the tension acting when they are connected by string, what is the tension acting through the string. All these matters we have to analyze. So that analysis cannot be done when you are, or it cannot be very easy when you are considering that whole system or that system as a whole. And what we are doing in free body diagram is we are isolating different parts of such systems. Different parts of such a system means different masses involved in that system, and we are expressing all the forces acting on that body part, in that parts of the system, with the help of vectors. We have a great weapon with us called vectors, which can express direction as well as magnitude of vector quantity. Since force is a vector quantity, we can easily express force in terms of a vector. So we are separating different parts of that system, and we are expressing the total force, or which are the forces, what are the forces acting on it, and these forces we are expressing in magnitude and direction with the help of vectors. Then we are finding out the acceleration of that particular system or the particular part of the system, and generally or finally we are expressing the tension. If their tension is the tension also we are expressing. Okay, so that is a method of analyzing with the free body diagrams, which means it's a method to analyze a complicated system. Realize first that free body diagram analysis is for analyzing a complicated system. Complicated system means connected system of connected bodies, and we are taking different parts of that body isolated and expressing all the forces acting on them with the help of vectors. Okay, so when we are going for the examples, that means when we are applying this free body diagram, then it will be more clear to you. Okay, so let us start with our free body diagram analysis. Okay, so in a free body diagram analysis, there are more than one body in that system. It is obvious, more than one body in that system, and each body is considered separately along with the forces acting on the body, that I already told you. Then the diagram showing the forces on individual body is called free body diagram. Diagram which shows the forces on individual body parts, that is called free body diagram. Okay, so first case we are considering is motion of two bodies in contact. Motion of two bodies in contact. I will explain the situation first. Let two bodies of masses m1 and m2 are placed in contact. I will show you that. See, we are having two masses m1 and m2 placed in contact, and they are placed on a smooth horizontal surface. They are placed on the smooth horizontal surface. Let a force F is applied on M1 as shown in figure. That means capital F. A force capital F is acting on M1 into the right horizontal direction. Let the contact force F develop between the two masses, which means you know about that contact forces, or when two bodies are in contact, there is a force developed between them, that is a contact force. M1 exert a force on M2 according to Newton's third law. M1 is getting back from M2, the same force. Okay, now this is a condition. We are having two masses in contact and we are applying force on one body and the body moves. Okay, so with what moment or what velocity or what acceleration, that body moves. With what acceleration that body moves, that we have to find out. For that, we are making use our free body diagram. I already told you what is free body diagram method. You have to consider the two masses separately. We have to express the two masses separately. So you see, the two masses m1 and m2 we have taken separately. M1 and m2 we have taken separately. See, then you have to express forces on each mass. We have to express forces on each mass. So what are the forces acting on m1? Obviously its mass weight is acting in the downward direction m1g, and its normal reaction r1 is acting in the upward direction. Then on m1 we are applying a force F. Then I already told you the contact force is getting back from m2, that is small f. And as a result of this force, in which direction that body moves in the right direction, in the applied force F, in the direction of applied force F. Are you getting that? When you consider the second mass is experiencing small f exerted by m1 in the direction of movement, and m2g is acting in the downward direction, and r2 its normal reaction is acting in the upward direction. So since there is no movement in the vertical direction, we can say that the weight and normal reaction on both the bodies are cancelling off. So r1 and m1g, r2 and m2g are getting cancelled. Then what is the net force acting on m1 now? F minus small f, which is equal to m1a. Why it is equal to m1a? Because it is moving towards the right direction with the acceleration a and its mass is m1. So m1a is the net force acting in the direction of applied force, but a minus f is acting in the opposite direction. So f minus f is equal to m1a. And on the right hand, second body, what is happening? Only contact force F is acting, and at the same direction the body is moving. So m2a is equal to F. The net force acting on that will be only due to F, the contact force exerted by m1. So this F you can replace by m2a. So what will happen? F minus m2a is equal to m1a, and minus m2a you can take to the right hand side. So F is equal to m1a plus m2a, that I written here as F is equal to m1 plus m2 into a. Therefore a is equal to F divided by m1 plus m2. And what is small f? The contact force. Contact force is m2a, and since a is equal to F divided by m1 plus m2, so F is equal to m2f divided by m1 plus m2. Is it okay? Now see the second diagram. In here m2, on m2 you are applying a force F. In m2 you are applying a force F, and m1 only experiencing the contact force. So this situation interchanges. At that condition all these equations will remain same. Instead the contact force. In that case, contact force will be m1f divided by m1 plus m2. That is simple logic. That is a simple logic. Okay, so that is the first case, motion of two bodies in contact. Motion of two bodies in contact. Okay. I think now it is clear to you. That means what is the method that we are choosing while we are discussing or dealing with free body diagram analysis. Okay, now you can go for another systems also, another systems of connected bodies also. So the first one is very simple one, another other systems also very simple, but this is simple in the sense there is no tension acting, and it is easy to understand what is the method that we have to choose in free body diagram analysis. So in free body diagram analysis, what we have done, we have taken the different masses separately, and we have expressed all the forces acting on that. With the help of that equations, we are finding out the acceleration, and now here the contact force. If the bodies are not directly contacted by through a string or thread, then instead of that contact force, the tension is acting there. So instead of contact force in such situations, you have to find out acceleration, then you have to find out what is the tension acting through the string connecting these two bodies. Are you ready? Come. Okay, now we can go for the second case, which is two bodies connected by strings and placed on horizontal plane. Bodies connected by a string and placed on a horizontal plane. You can see the diagram, the first diagram, m1 and m2 are connected by a string, and a force, it is pulled by a force from the side of m2 towards the right direction. Okay, so a tension will be acting on the string, on m1 tension is acting towards m2, and on m2 the same tension is acting towards m1 according to the third law of motion. Okay, now here also we have taken the two masses m1 and m2 separately, and we are expressing the forces on m1 and m2. And see, on m1 what are the forces acting? Vertical direction, obviously m1g is acting in the downward direction, r1 is acting in the upward direction. They will cancel off since there is no movement at all in the vertical direction. And on the horizontal direction, only one force is acting, that is the tension, which is acting towards the right direction. And as a whole, if the as a whole system as a whole, due to the force F, it is moving towards the right direction. So T is only force which is responsible for the motion m1a. So the first equation you can write T is equal to m1a. That is the equation that first equation that we have written here, T is equal to m1a. Okay, then for the second body, r2 and m2g are getting cancelled, and F and T are acting, F is acting towards the right direction, T is acting towards the left direction. Body is moving towards the right direction with an acceleration a. So forces acting in the direction of movement, you can take it as positive. So what is the net force acting on m2? That is m2a, since it is moving towards the right with a fellow acceleration a. And force F is acting in the same direction, and T is acting in the opposite direction. So we can say that m2a is equal to F minus T. Are you getting that? Yes, it is very simple. And T is, we have already written T is equal to m1a. So what we can do, T you can replace by m1a. So F is equal to m1a plus m2a. So A is equal to F divided by m1 plus m2. Again, very simple equation. And what about T? A is F divided by m1 plus m2, and T is equal to m1a. So m1 into F divided by m1 plus m2. That will be the tension acting. Is it simple? Yes, it's a simple free body diagram analysis. Okay, so here I already told you there is no direct contact, so non-contact forces are there, that is a tension and acceleration we have calculated now. Okay. Again, if the force is acting on M1, what will happen to the acceleration? Acceleration will not change, it will remain the same, but tension is changing as M2F divided by M1 plus M2. In the first case also we have seen that. So again, A is F divided by M1 plus M2 and T is equal to M2F divided by M1 plus M2 if the force is acting on M1. Okay, it is clear. Now we can go for the third condition or the third situation where two bodies connected by a string passing over a smooth pulley. Can you imagine that diagram? Two bodies are connected by a string and that string is passing through a smooth pulley. Can you imagine? I will show you. See, we have two bodies B and A. We are having two bodies B and A. B is having the mass M2 and A is having the mass M1. B is having the mass M2 and A is having the mass M1. And M1 is greater than M2. From the diagram it is very clear. A is massive than B. So M1 is greater than M2. Is it? Now, if you are having such a situation, obviously A will move down and B will move up. So the acceleration on B is in the upward direction and acceleration in the on A will be in the downward direction. We have to find out what is the acceleration and what is the tension on the string. For that, we have to go for free body diagram analysis. How it can be? You can take the two masses A and B separately. We have taken A and B separately and now we have to express the forces acting on that. Obviously M1G is acting in the downward direction, tension T is acting in the upward direction and the body is moving in the downward direction with an acceleration A. So M1A is equal to M1G minus T. Why? Because forces acting in the same direction of motion you have to take as positive and the opposite force you have to take as negative. So M1G you have to take as positive and T can be taken as negative, which is equal to M1A. What about the second body? A is acting in the upward direction. That means acceleration is acting in the upward direction. T is in the direction of the movement and M2G is acting in the downward direction. So T minus M2G is equal to M2A. No doubt about that. Is it? Then when you are adding these two equations, you will get M1 minus M2 into G is equal to M1 plus M2 into A. Because in the left hand side you are having T and minus T, they get cancels. M1G minus M2G that you have taken as M1 minus M2 into G in the left hand side, and on the right hand side you are having M1A plus M2A that you have written as M1 plus M2 into A. So what is acceleration A? A will be M1 minus M2 into G divided by M1 plus M2. A is equal to M1 minus M2 divided by M1 plus M2 multiplied by G. You have to find out the value of T. A we have got and now we have to calculate the value of T. How we can calculate T? You have the equation M1G minus T is equal to M1A. So T will be M1G minus M1A. M1G minus M1 into what is A? M1 minus M2 into G divided by M1 plus M2. On the right hand side you can see that. Then M1G is there and here also M1G is there. That M1G you can take as common. So M1G into 1 minus M1 minus M2 divided by M1 plus M2. Okay, now you can cross multiply there. When you are cross multiplying M1G that will remain there. M1 plus M2 will come there, minus of M1 minus of minus M2 that will become plus M2. So from the bracket M1 and minus M1 get cancels, M2 minus of minus M2 will be there. So 2M2 divided by M1 plus M2 will be there and inside the bracket. M1G will remain there. So that will be 2 into M1 M2G divided by M1 plus M2. So the tension will be T is equal to 2 M1 M2 divided by M1 plus M2 into G. Is it clear or not? Yes, it is clear. So it is very simple. We how to consider the two masses as separate masses that we have expressed here. Then express the forces in terms of vectors. Then find the equation. And when writing the equation, moment you have taken, that is m1a or m2a, whatever may be, and the forces acting in the direction of m1a and m2a, that you have to take as positive, and other forces acting in the opposite direction you have to take as negative. That only you have to do there. Okay, now we have written equation for m1 and m2. These two equations, they are adding, and we are getting these equations as such. So that is the third condition. Body is connected by string passing over a pulley. Okay. The fourth condition is body is connected by string, one placed on smooth table and the other is hanging down. Okay, so the table is smooth and mass of body A is m1, which is suspended freely, and body B with the mass m2 is placed on the horizontal table, and it is a smooth table, there is no friction. Okay, and body m1 is moving down and m2 or the body B is sliding towards the right. So here A is acting on B in the horizontal direction, on m1, that is the body A, it is acting in the downward direction. Again we can start with the free body diagrams. So free body diagrams are here. For m1g is acting in the downward direction, tension is acting in the upward direction, and acceleration in the downward direction. So what will be the equation? Equation will be m1g minus t is equal to m1a. Okay, and for the second body B, m2g and r, they are getting cancelled since there is no movement at all in the vertical direction, and it is moving towards the right direction with an acceleration a due to the tension A. So T is equal to m2a. This T you can replace by m2a. When you are adding these two equations, T and T get cancels. So m1g is equal to m1a plus m2a. So m1g is equal to m1 plus m2 into a, and a is equal to m1 divided by m1 plus m2 into g. What is tension T? m2a. A is equal to m1g divided by m1 plus m2 multiplied by m2. So T is equal to m1 m2 divided by m1 plus m2 into g. Okay. So that is the free body diagram analysis. What do you feel now? Is it tough or easy? It is very easy if you know the vector concept and the force. With the help of these Newton's laws of motion, we have made a concept regarding the forces, its direction, equal and opposite forces, action and reaction and all. And with the help of vectors, we know how to express these forces with their magnitude and direction. Which directions you have to take as positive and which directions you have to take as negative. So keeping all these in your mind, analyze with taking the different parts as separate masses and express the forces acting on each mass with the help of vectors. That is only free body diagram analysis. Okay, so one more thing I have to tell you in this chapter, that is concurrent forces. Concurrent forces. Again, it is something related to force. And you know, suppose you are having an object and there are number of forces acting on the same object, which means different forces are acting from different directions, and on that body they are meeting because all these forces are acting onto the same object. So these different forces are meeting at a point. These forces are acting to a particular point. In other words, we can say that line of action of these forces are meeting at a point. That is simply what happens when different forces are acting on a single object from different directions. So such forces whose line of action meet at a point, they are called concurrent forces. They are called concurrent forces. So the forces whose line of action meet at a point are called concurrent forces. See, here we have F1, F2, F3. Their line of action are meeting at the point O. F1 is making an angle alpha 1 with the x-axis, F2 is making an angle alpha 2 with x-axis, and F3 is making an angle alpha 3 with x-axis. So you can find the magnitude of F1, F2, F3 acting along the x direction as well as y direction. So the resultant force acting along x axis will be the component of F1, F2, F3 along x direction. So what is the component of F1 along x direction? F1 cos alpha 1, that we have already seen using the resolution of vectors. Similarly, of F2, that is F2 cos alpha 2, for F3, that is F3 cos alpha 3. So the total force acting in the x direction will be F1 cos alpha 1 plus F2 cos alpha 2 plus F3 cos alpha 3. Is it? What about the y component? Sine component. So F1 component of F1 along y direction will be F1 sin alpha 1, F2 sin alpha 2 and F3 sin alpha 3, corresponding or respectively from F2 and F3 acting in the y direction. So the net force acting in the y direction will be F1 sin alpha 1 plus F2 sin alpha 2 plus F3 sin alpha 3. Okay. So that is a component of these three forces acting along x direction and y direction separately, respectively. And the concurrent forces is the forces meeting at a point. Simple words we can say different forces meeting at a point. So these forces are called concurrent forces. The major role of these concurrent forces is in practical situation. In a practical lab, you are going to do an experiment called parallelogram law of vectors. In that, you are making use this concurrent forces. In that, you are making use this concept of concurrent forces. So, in the practical class, we will practice these concurrent forces with the help of an experiment. So, you remember that what is concurrent force. So, concurrent force are the forces meeting at a single point. That is concurrent force. So, that's all about this chapter, Newton's laws of motion. Newton's laws of motion. Okay, so one more topic is in the textbook, one more topic is there, the apparent weight of a body in a lift, but that is not there in your syllabus. Okay, so according to the syllabus, all the matters from this Newton's laws of motion we have discussed. Okay, so revise this chapter, revise the concept behind all the laws of motion and applications of laws of motion, then free body diagram analysis, and finally concurrent forces. Okay, we will meet in the next class. Till then, bye.